Stop scrolling if you want to know what's actually happening in the world today. We live in an era where every morning brings a new headline, but most of them are just noise. Today, we're cutting through the clutter to reveal the real stories shaping our future. From the microscopic secrets of our own cells to the vast mysteries of deep space, discover how science is rewriting the rulebook right now and why these discoveries matter more than you think. Let's start at the very bottom of everything. For decades, we thought we understood biology, but recent breakthroughs in CRISPR-based editing have shattered our previous understanding of genetic inheritance. Scientists aren't just reading DNA anymore. They are rewriting it with surgical precision. Imagine a world where you could correct the gene responsible for cystic fibrosis before birth or eliminate the genetic markers for Huntington's disease entirely. This isn't science fiction. It's happening in clinical trials right now. In 2024, researchers successfully edited out a pathogenic gene from human embryos with unprecedented accuracy, showing that the tyranny of the two parents might soon be obsolete. But beyond medicine, this is changing agriculture on an industrial scale. We are moving away from crossbreeding and toward gene-drive technology in insects. By tweaking the genetics of malaria-carrying mosquitoes to prevent them from spreading the disease, we could theoretically eradicate it from specific regions within a few years without spraying toxic chemicals. The implications for global public health are staggering. What was once considered a distant dream is now a logistical project waiting for funding and regulation to catch up. If you were thinking the microscopic world is where all the action is, wait until I talk about what's happening above us in the quantum realm. We are on the precipice of a second quantum revolution. 10 years ago, quantum computing was just a theoretical curiosity, but now we have machines that can solve problems classical supercomputers simply cannot touch. Take the simulation of complex molecules for drug discovery. A classical computer would take millennia to model how a protein folds and interacts with a virus, but a quantum processor can do it in minutes. This means we are looking at a future where personalized medicine is instantaneous. Your doctor could run millions of simulations on your specific genetic makeup overnight to find the perfect treatment combination before you even walk into their office. Furthermore, the development of room temperature superconductors has been making headlines, promising to eliminate energy loss in power grids entirely. While we aren't there yet, prototypes are showing us that electricity could travel across continents without a single watt wasted as heat. This is the key to unlocking clean energy at scale, turning solar and wind into reliable baseload power sources that don't depend on weather patterns or massive battery farms. While we're looking down to the cell and up to the quantum machine, let's lift our eyes to the stars. The James Webb Space Telescope has fundamentally altered our view of the universe's history and composition. It hasn't just taken better pictures, it has seen further back in time than ever before, detecting the first galaxies that formed after the Big Bang. These observations challenge our standard cosmological models. Scientists are now reevaluating how quickly the early universe expanded, suggesting we might need to tweak Einstein's equations of general relativity to explain what they're seeing. It's a paradigm shift on a cosmic scale. We are realizing that the building blocks of life, including carbon and nitrogen, were forged in the violent collisions of neutron stars billions of years ago. Every element you touch has a story of death and rebirth written in its atomic structure. But it's not just about distant objects. It's about our place within the cosmos. The discovery of biosignatures on exoplanets is no longer science fiction. Spectroscopic analysis of atmospheres around potentially habitable worlds is revealing chemical imbalances that suggest biology, or at least complex chemistry, might be common in our galaxy. We are realizing we are not alone in a cosmic sense, but the nature of life itself might be vastly different from what we expected. So why should you care about these discoveries? Because they are practical tools for solving today's biggest problems. Climate change, resource scarcity, and disease are not inevitable fates. They are engineering challenges waiting to be solved with the right data. Consider artificial intelligence in climate modeling. AI algorithms can now predict weather patterns weeks in advance with high accuracy, allowing governments to prepare floods and droughts with months of lead time instead of days. This proactive approach saves billions of dollars and countless lives annually. Similarly, Synthetic biology is being used to engineer bacteria that break down plastic waste or capture carbon dioxide from the atmosphere directly, turning pollution into raw materials for new products. The most surprising insight: the speed at which these technologies mature means we are already living in a future that feels like it belongs to someone else's science fiction novel. We have the capacity to reverse course on many of our current environmental and health trajectories if we choose to apply this knowledge wisely. The tools exist. The only variable left is human willpower and implementation strategy. From rewriting our DNA to exploring the birth of galaxies, these are just a few of the stories unfolding right now in the labs and observatories around the world. Science isn't a static museum exhibit. It's a living, breathing engine driving change faster than ever before. The discoveries we discuss today prove that our understanding of reality is expanding every single day. If you enjoyed this deep dive into the cutting edge of science, hit that subscribe button and ring the notification bell so you never miss an update. Drop a comment below telling me which discovery surprised you the most or which field you want to explore next. Let's keep the conversation going in the comments section.